Hi, and welcome to day one of trig formulas. This is the start of the unit where we're actually going to get the formulas that you're going to need and use the reference sheet for on the final exam. So, the first thing we're going to start off with is the function of the sum of two angles. The sum of two angles means I'm taking two angles and I'm adding them together. If I have the sine of a plus b, it is equivalent to sine a cosine b plus cosine a sine b. If I have cosine of a plus b, that's cosine a cosine b minus sine a sine b. And the tangent of a plus b is tan a plus tan b over 1 minus tan a times tan b. Okay, these formulas will be given to you on the final exam. You just have to know how to use them and when to use them. So for example number one, what is equivalent to cosine 10 degrees, cosine 13 degrees minus sine of 10 degrees, sine of 13 degrees? So what you need to do is look and see which formula this matches. This is a cosine. A is my first angle. Another cosine, a different angle, which is B, minus the sine of the first angle, because they're the same, and, oops, that's the sine of b, because that matches the second angle. So if cosine A cosine B minus sine A sine B, and if you look, that matches the cosine A plus B formula. And in this case, A is 10 and B is 13. So it's the cosine of 10 plus 13, which is equal to the cosine of 23 degrees. Okay, all we're doing is kind of working our way backwards. For b, if I have sine x cosine y plus cosine x sine y, x and y, a and b, what difference does it make? If you look at which formula it matches, sine cosine matches the sine a plus b, so this is equivalent to the sine of x plus y, and since they're not like terms, I can't add them. And this time, I have the sine of 90 plus x. So I need to use my formula of my sum of two angles and expand. So I'm going to say sine of 90 times the cosine of x plus the cosine of 90 times the sine of x. Well, we can use our unit circle to evaluate 90 degrees. 90 degrees is up here, and this is the point 0, 1. So the sine of 90 is the y value, 1, times the cosine of x, plus the cosine of 90 is 0, times the sine of x. Well, that's going to zero out, and we're just going to be left with cosine x. All right, next problem. Number 2, verify that the cosine of theta plus pi is equal to minus cosine theta. Well, this is the cosine of a plus b, so I have to use my cosine of a plus b formula. And a is theta, b is pi. So that means we're going to have cosine theta, cosine pi minus sine theta, sine pi. Oops, that should be theta. Sine theta, sine pi. Getting ahead of myself here. Pi is 180 degrees. So using our unit circle at 180 degrees, we have the point -1, 0. So cosine theta times the cosine of pi, well, that's x, so times -1, minus sine theta. Sine of pi is 0, so that all goes away. So you're left with a negative cosine theta, which is what they asked you to verify. So that's good. Find the exact value. You know what that means? No calculator. So either your special right triangles or your unit circle. Of the cosine of 75 degrees using the cosine of 45 degrees plus the 30 degrees. So this is a cosine of the sum of two angles, so I have to use my cosine formula, which is the cosine of 45, cosine A, cosine B, which is 30, minus sine of 45 times the sine of 30. So you need to use your special right triangles. These things still have not gone away. Cosine of 45 is adjacent over hypotenuse, which is 1 over radical 2, which is radical 2 over 2. Cosine of 30 is adjacent over hypotenuse, which is radical 3 over 2. Minus the sine of 45 is 1 over radical 2, which is radical 2 over 2. And the sine of 30, opposite over hypotenuse, is 1/2. I have to multiply before I can subtract, so I have radical 6 over 4 minus radical 2 over 4. I have a common denominator, but my numerators are not like terms, so it's radical 6 minus radical 2 over 4. I cannot simplify that because I cannot divide underneath the radical if I don't have a radical in the denominator. So this is my final answer. For number 4, move this out of the way here. If the sine of x is equal to 4/5 and the measure of angle of x is in quadrant 2, and the cosine of y is equal to negative 5/13 and angle y is in quadrant 3, find sine of x plus y. Well, we need to expand our formula. This becomes sine x cosine y. Again, I'm using the formulas from the top of the sheet, x plus y plus cosine x sine y. Well, I know what the sine of x is equal to, and I know what the cosine of y is equal to. I don't know what the cosine of x is, and I don't know what the cosine of y is, but I have enough information that I can draw a picture. X is in quadrant 2, and this is x. Sine is opposite over hypotenuse, and this side is 3. So we were told that sine x is equal to 4/5. Cosine x is going to be negative 3/5. Oops. My bad. It's supposed to be in quadrant 3. Cosine is 5/13, negative 5/13, so it's negative 5. My other side is negative 12 because it's a 5, 12, 13 triangle. It's the other triangle you need to be familiar with, like a 3, 4, 5. If you don't know what it is, you have to use the Pythagorean theorem. And we know to find the sine. We already know that the cosine of y is negative 5/13. So sine of y is negative 12/13. So substituting those values into my formula, sine x is 4/5. Cosine y is negative 5/13 plus cosine x is negative 3/5 times the sine of y is negative 12/13. So I will have negative 20 over 65. Two negatives make a positive, so it stays positive, plus 36 over 65. And when I combine like terms, I will get 16 over 65. Using that same information, I can find the cosine of x plus y. I need to use my formula, expand there, so it's cosine x, cosine y minus sine x, sine y. Again, I'm looking at the front of the sheet there. Same information. I still need sine x, cosine y, cosine or sine y. Okay, all the values. So cosine x is still going to be negative 3/5. Cosine y is negative 5/13 minus sine of x is 4/5, and sine y, oh, hang on. Okay. Sine y is negative 12/13. So when I multiply here, I will have 15 over 65. I have two negatives, which will make a positive. 4 times 12 is 48/65. And when I add the two together, I get 63 out of 65. Tangent has its own formula. And my tangent formula is tan x plus tan y all over 1 minus tan x times tan y. Okay, I didn't find my tangents, but if I go back to my triangles, the tan of x is going to be opposite over adjacent, so negative 4/3, and tan y is going to be opposite over adjacent 12/5. So I can see what I'm doing here. So tan x is negative 4/3 minus tan y is 12/5 all over 1 minus negative 4/3 times 12/5. So I'm not going to do anything with my numerator quite yet, but I am going to multiply my denominator. That's two negatives, so it's going to become plus 48 over 15. I have a complex fraction. I think the easiest way to deal with this is to just multiply by the LCD, and my LCD is 15. So we multiply everything by 15. So here the 3 and the 15, 5, so it is negative 20. 5 and the 15, that becomes a 3, plus 36 over 15. 1 times 1 is 15. Those 15s cancel out, plus 48. So negative 20 plus 36 is 16. And 15 plus 48 is 63. Now, if I really want to check my work, part A was sine, part B was cosine. Sine divided by cosine is tan. It should still work. My first answer was 16 over 65. Sine divided by cosine, it was 63 over 65. Multiply top and bottom by 65, because that's my LCD. They cancel, and I'm left with 16 over 63. So that still holds true. All right, next problem. We're going to solve sine of x plus pi over 4 plus 1 equals sine of pi over 4 minus x between 0 and 2 pi. Actually, we're going to hold off on this question. We'll come back to this in class. We'll do this together. The next thing we have is the difference of two angles, which is just like the sum of two angles, except this time I have a minus sign in between. My formulas are pretty much the same. The only thing that's going to change is my signs in the middle. Okay, all my signs change their opposites when I have the difference of two angles. So let's try some problems here. If the sine of x is equal to 4/5 and the cosine of x, or negative 4/5, and the cosine of x is equal to, oops, that should be cosine of y. On your paper it says y. Negative 4/5, x and y are in quadrant 3. Find the cosine of x minus y. Well, let's draw our triangles first. We are in quadrant 3. X sine is opposite over hypotenuse. That makes this side negative 3. And we know that sine x is equal to negative 4/5. Cosine x would be negative 3/5. Y is also in quadrant 3. And the cosine, excuse me, is negative 4/5. So that makes this negative 3. So the sine of y is negative 3/5. And then cosine of y is negative 4/5. I'm going to find my formula and expand. And cosine of x minus y is cosine x cosine y plus sine x sine y. So I have all my values written over here on the left. Just going to substitute in. Cosine x is negative 3/5. Cosine y is negative 4/5. Plus the sine of x is negative 4/5. And the sine of y is negative 3/5. Negative times negative is positive, so it's 12/25. Again, two negatives make a positive. And I still have 12/25, so it is equal to 24/25. Alright, next one. Find the exact values of the sine of 75 using the sine of 120 minus the sine of 45. Exact values, again, means our right triangles or our unit circle. So we have the sine of 120 times the cosine of 45 plus, oops, sorry, that's minus, wrong formula, minus the cosine of 120 times the sine of 45. Okay, we have our 45, 45, 90. And that would be in quadrant 1 in case you were wondering. So it's 1, 1, radical 2. And if I'm at 120, I'm in quadrant 2. This is 120. which makes my reference angle 60, which makes this 30, so that means that this is 1 radical 3 and 2, and the 1 is negative here. So we need the sine of 120, or sine of 45, we already know is radical 2 over 2. The cosine of 45, we already know is radical 2 over 2. And the sine of 120 would be radical 3 over 2. And the cosine of 120 would be negative 1/2. So we just substitute in. Sine of 120 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Minus the cosine of 120 is a negative 1/2. And the sine of 45 is radical 2 over 2. So we have radical 6 over 4 minus a negative, so plus radical 2 over 4, which is radical 6 plus radical 2 all over 4. Right, we will stop there and work on number 5 and 3 and 4 together in class tomorrow.